With this problem, we're going to look at the discontinuity of a radical, which doesn't make much sense, but if you think about it, it makes total sense. We've got the square root of 7x plus 2 here. Here's a graph of what it looks like. I've zoomed in fairly close to the origin so we can see exactly what's going on. But the question is, what kind of discontinuity do we have, and what type of discontinuity is it? Well, the type of discontinuity is a little bit tricky because there's a jump discontinuity, which it is not. There's an oscillating, which it is not. There's a removable, which it is not. So there's several types, but it is not continuous where the radical is undefined. And anytime you're dealing with a radical, the numbers inside the radical have to be larger than or equal to 0. Because for now, we're not going to deal with negative square roots. So when I solve this out, this tells me all the possible values of x that I can put into this function and get an answer that will be continuous and in its domain. So if I just look at the kind of the opposite of that, everything less than negative 2/7 would be where I'm discontinuous. And I'm discontinuous because if I try and put a number in, like let's say, here's 5, if I try and put negative 3 in there, I can't do that for this graph. There's nothing available for me to see. Or if I try and put a negative 1 in there, I can't do that for this graph. There's nothing in there for me to see. And so that means that I'm discontinuous from negative 2/7 towards negative infinity. And we could even write it like this. All right, with this problem, we've got a piecewise function here, and we want to find out all the points of discontinuity. And we can tell by looking at our piecewise setup that the one place we're really interested in is right here. And, oh, maybe something goofy happens in here. We don't know. So let's go ahead and take that x squared minus 4. And let's factor it out and see if anything will cancel out. And when I do that, I get x plus 2, x minus 2 on top. And on the bottom, I get x plus 2. And so the x plus 2's cancel out or divide out, whichever you prefer. And I'm left with the line x minus 2. What this means is I have a hole at x plus 2. I'm going to have a hole at this point. So when I take that x plus 2 and set it equal to 0, I'm going to see that there's a hole at negative 2. And hey, that's the point that they showed us up here that we're interested in. So they gave us a specific definition for that hole, and they said when x equals negative 2, we're going to have a y-coordinate of 7. But as you can see, when x equals negative 2, it needed to be a y-coordinate of negative 4 to be continuous. So where is this function discontinuous? When x equals negative 2. It's actually, this one turns out to be discontinuous at the point that we're interested in. All right, with this problem, what we want to do is find a formula for an extended function where we won't have any discontinuities in the problem at all. And to do that, what we want to do is look for anything that might factor out of the top and bottom. We're especially interested in what's going on when x equals 4. So, when x equals 4 is somewhere right around in here, and we are currently undefined at that spot. So what I'm going to do is I'm going to factor the top, and this is a cube minus a cube. And if you are factoring and you have a cube minus a cube, it factors this way. And so basically my x cubed minus 64 becomes x minus 4 times x squared plus 4x plus 16 all over, and then factor the bottom also, x plus 4x minus 4. And remember, we're just concerned about being continuous when the point is equal to 4. So if you'll notice that the x minus 4s will divide out or cancel out. And what I'm left with is the extended function at that particular point. So once we get to this part, we are done with this problem. We're now defined at the point that we were interested in, which is this guy right here. And we're ready now to draw a line that's continuous at that particular spot. We're not worried about the minus 4 with this particular equation.